Hello, can everybody see the slides?
Yeah,
And also, is this, you see the slides scrolling down?
I don't.
Okay. Can everybody see the slides?
Yeah.
Okay, great. And also, is this, you see the slides scrolling down?
I don't.
Okay. Okay, great. Yeah, let's just wait for 2 to 3 minutes to ensure everybody joining. Oh, by the way, any echo now?
Doesn't seem like it.
No echoes, right? Okay, great. Okay, I think it's right time to start. So hello everyone. So welcome to the first class of machine learning, CS5350, 6360 in this spring semester. So as you know, throughout the semester, we're gonna still use this online teaching. This is a little bit weird and awkward, but hopefully, when the COVID, those kind of things can be controlled, we're going to return to normal. So, so this semester I'm going to teach this class. So my name is Shandian Zhou, but you can call me Shandian Z or just Shandian because this last name is not easy to pronounce. Just call me Z or Dr. Z will be fine. So I would like to briefly introduce myself first. Yeah, so I'm very, I'm very glad, I'm very happy to teach this class, teach this course, because this is my own area. I'm working in this area for like more than 10 years, I guess 12 years or 15 years. So I'm assistant professor from School of Computing at University of Utah. So my research area focuses on the so-called probabilistic machine learning, well, you can say it's kind of branch of machine learning. I prefer to use probabilistic framework, Bayesian framework to formulate machine learning problems and also develop learning algorithm. In that I'm care about not only the point estimations, but also the posterior distributions. That will be more robust and give you a lot of uncertainty information. So, throughout the whole, I mean, my like, it's not very long time working on this area. I've seen with my eyes how this area from popular becomes extremely popular, from prosperous becomes extremely prosperous. Right? So like when I was a PhD student, we as a PhD student we have to submit papers to like top venues like New York NIPS, like SML, UA, those kind of conferences every year. At that time, like every year, normally the total submissions will be like a few hundreds, like 300, 400. That's pretty normal. And then in the middle of my PhD study, like I guess that is 2014 or 15, I forgot. But anyway, that year, the number of submissions was like 2,500. So people in this area, people in this community is kind of like surprised, shocked. It's kind of okay. People are crazy. So many submissions on that. But guess what? Like last year, I submitted paper to New York NIPS, of course, with my student. Guess how many submissions to this conference? New York NIPS. Nearly 100K, not 100, 10, nearly 10K. It's very crazy. There are so many like submissions, such that the community, the program community, the program committee cannot find like enough qualified reviewers, so they come out. Finally they come out a way, which is kind of like a incur a lot of like criticisms. They do some kind of so-called desk rejections, meaning that they claim that some people, like some senior people, like every chair, they will just roughly look at your abstract and perhaps introduction, and then decide whether decide to reject you, even without distributing your paper to the reviewers. So many of my friends just complain to me. They feel like these are done by machines. So you can imagine like how popular, how hot this research area. So I'm excited because this is not only some kind of like overhype of usefulness, but really machine learning is everywhere. We're going to discuss a few applications, and you say how amazing the progress of machine learning have achieved in recent years. So yeah, so briefly speaking, my research topics, examples include like Bayesian nonparametrics, Bayesian deep learning, graphical models, large-scale learning system, complex data structure factorization, embedding learning, all kinds of stuff. And also I'm very interested in applying machine learning to address a lot of problems like collaborative filtering, in other words, recommendation, right? And the online advertising, physical simulation, like how do you use machine learning, especially neural networks, to solve partial differential equations, right? It's kind of incredible, but it's working really well. And brain imaging data analysis, like how do you analyze like billions, not billions, like gigabytes data generated by fMRI scan machines, right? So today we're gonna cover a few things. So first, we'll discuss some definition of machine learning. Right now that we want to learn machine learning, we want to go to the entry of this area, right? So we need to know what is the proper definition for that. So what kind of applications for machine learning, right? What kind of successful applications? You'll see that actually machine learning is everywhere. You might not be aware of that, but it's there. And also, I would like to briefly introduce the course content, and then important things are here: course requirements and policies. So including homework assignments, project, final exams, and the workload and some logistics. Those are really important because this is what I have told to many students who requested the permission code before. So this course is quite challenging. So I want to spend a little bit more time to explain the workload and suggest how much time you should plan for this course. Otherwise, you might feel too challenging or even feel tortured. I don't want students to be tortured. I want you to learn something. But if you really want to learn something, you need to commit some time and efforts. Yeah, any question? Any question for this? Okay, and finally we'll give some basic knowledge review, like random variables, what is definition of the mean or expectation, what is variance, what is independence, such on. You might have noticed the release of the first homework zero. So that is just to help you review the basic concepts you have learned before, maybe in your first year, your college or second year, and get ready to see some like details about machine learning algorithms and models. Okay, so so first let us talk about what is learning and what is machine learning. So could anybody give me some kind of your thinking, your thought about the definition of learning? Definitely, everybody is learning, right? Including you, right? You are learning something, right? But what is learning? How do you define learning? Anyone willing to share your thought?
I think it's the process of assimilating and applying new knowledge.
Yep, sounds good. And also, I say, they were saying, okay, the acquisition of new knowledge. Yeah, exactly. Okay, I'm about to learn the definition of learning. Quite paradox. Okay, so I think what you guys just said, like talking about acquisition of new knowledge, assimilate new knowledge. Yeah, from a procedure perspective, that's very accurate. That's correct, right? But think about another way, like think about what is the outcome of learning, right? So after all the learning procedure, what can we gain? Can anybody give me thoughts in this direction or aspect?
I think thinking about something that you gain from learning is that you look at real world examples and you look at data, and then that gives you some kind of construct so that you can either predict outcomes or you can have expectations for what will happen based on the things you already know, even if you've never directly experienced the thing before.
Yes, very good, very good. Yeah. So, and also I also find some answer in the chat box. Someone said, okay, getting better at the skill with experience, right? Yeah, really good. One short sentence hit all the points, right? And observe a pattern in other behavior and collect data about how to appropriately interact. Sometimes subconscious is done. Yeah, but this is more like, this definition is more like, psychology view. Yeah, but from our perspective, from computer science perspective, right, we're more we'll look at more like how kind of effect through learning procedure. Why? Because we want to develop some automatic algorithms, right, to achieve same kind of effect as human learning. Right? So we know, okay, after human learning procedure, we gain some experience in doing something, right? We gain some improvement in doing something, right? So basically, based upon that observation, that this observation actually motivates us to develop a computer program, like to do the same thing. Like once you feed some kind of data to that program, they can learn some capability to improve doing something, or to deal with situations they have never seen before. So to give a more concrete idea about the learning procedure, let us talk about a game, right? Let's play a game which was played like about 3 decades ago, right? That is at the early time of machine learning. right? So this game is called the badges game. So the attendees of the 1994 conference at this conference is called Computational Learning and Theory. It's the top machine learning conference. It's about learning theory. It's more theoretical perspective. And those attendees, they received conference badges, right? So in the badges include names and organizations and emails and so on. But this time, their badges also have labels like positive or negative. But this positive and negative does not mean you're bad, you're a good guy or a bad guy. It's just some kind of label. And among those attendees, there's only one person who knew the function that generated the labels, right? And the attendees who received labeled badges only know that, okay, this function depends only on the attendees' names, right? Does not depend on anything else. Right? So now, those attendees are assigned a task, right? Collect as many example badges as possible, and then find the unknown function. Right? So here I give you a set of badges. Right? So this Claire Cardio label, this badge is labeled as negative. Peter Bartlett, positive. Eric Baum, negative. Michael Jordan, positive. All those guys are big names. A big names mean machine learning, right? They were famous like 20 years ago or 30 years ago. So now, suppose you were one of these attendees and you have collected this set of labeled badges. Now, can you come out a function that generates these labels? Could everybody give me an idea, like even guess, like just by a guess, by observation?
Could it be based off the number of characters in the first name? Whether they're an even or non-odd number of characters.
Okay, so let us verify it. Okay, so the negative label, it is okay, 6 letters is even, right? And 5 odd, 4 and 7. Wow, bingo, you're right. Perfect. Any other suggestions? Any other proposal? It's just give me a random guess. That's fine. There's no. Actually, I have no idea about the ground truth as well.
Be the inclusion of specific characters.
Yeah, it's fine. It can include the special characters like if they include like some letters as the first letter of their family name or first name, etc. Oh, nice. Someone said, okay, if the first name is Michael or Peter, then give positive, and otherwise give a negative. That's very interesting, right? So yeah, your rule is perfect for this 6 examples, right? But learning, as we discussed later, right? There has an important capability. It's a generalization, right? We'll come out with this like strong rule. You need to think about if it is possible to apply to other unseen badges, right? But anyway, this is a good proposal, right? Yeah, maybe a function of number of vowels and number of the consonants. Yeah. And positive if the first name ends on I or R. Okay. LR. Okay. Okay. Yeah. Nice proposals. Okay. Great. So far we have you guys have proposed quite a few functions, right? Every function accurately generates those labels. Right? And then the problem is, how do you verify the effectiveness of your function? How to do that? So now we have like at least 3 or 4 functions, each of which can perfectly label those badges, right? But now a natural question comes, right? How do we rank them? How do we choose them? Any suggestion or any thoughts on that? Any proposal on that? Yeah, I've seen some messages, right? Test set, right? Test them with larger samples. Yeah, exactly. It's naturally right. We should collect a way more set of badges, right? And use our proposed functions to test, right? If all of them like fit is consistent with our prediction, yeah, you win. Right. So now, throughout this simple game, right? Throughout this simple game, we actually experienced a learning procedure. Right? We collect first, before we conduct learning procedure, we collect a set of examples, right? Namely, this set of badges, right, with knowing labels, either positive and negative. And then from those examples, we extract some patterns and we represent our learn function in terms of based on those patterns, right? And then the last stage will be verify the effectiveness of our learn function, as some of you have suggested, right? We can collect another set of examples or badges, right? And we use our function to make prediction and test if our predictions are correct or not, right? If it is correct, okay, you win. Otherwise, you might need to go back and look at how to improve your function. So someone asked, what was the actual function used at the conference? I have no idea. I'll try to find out and probably release them after the class, right? But this simple game is just to give you a hint, right? How a typical learning procedure is conducted. Now, if we replace the players by machines, it is a machine learning procedure. You collect the set of badges, example badges, feed them to a machine learning algorithm, like your Python algorithm, your MATLAB algorithm, and your algorithm gives some kind of proposal of prediction function, and you test them with new examples. So this is typical machine learning procedure. So now, although the examples we just mentioned is really simple, right? but in real world there are many complicated examples, right? Like playing Go games, like AlphaGo. So how many people have heard of this AlphaGo? Or how many people have heard of Go games? Okay, looks like many. I thought Go game is not very popular here. I know the chess game is very popular, right? The Go game is not very popular. Okay, great. Yep. So here I want to share some gossip with you. I mean, throughout my life experience, my whole life, when I was young, when I was small, actually, when I was in a junior school, there's like a breaking news. I think it's 1997. Right? IBM developed his powerful machines called Deep Blue, who won the world champion of chess game. That world champion is a Russian player. He's kind of like a legend in chess game. His name is Kasparov. Anyone heard of him? Okay, yeah, he's kind of really a genius and talent, but he was defeated by IBM's machine, right? and the developer of that machine is a guy from CMU. This is kind of breaking news. But then people ask that if this is artificial intelligence, the main developer said no. This is not. There's no artificial intelligence here because the essence of that algorithm is kind of like very smart search algorithm. So you can imagine that you play a step and then your opponent take a step, and you can enumerate all possible steps and end up with win or not win, right? So if you have like numerous computing resources, you can imagine your computer can enumerate all possible steps, right? And you can just choose the step will finally lead you to win. But unfortunately, this is not possible, right? Because the whole steps, the whole space of which contain all possible playing procedures is so huge. So those IBM people actually develop a very fast searching procedure plus smart pruning strategies, so that you don't necessarily need to search over those hopeless steps. This is their idea, right? And then people naturally want to transplant that idea to do this Go game, but they failed because Go game is way more complex than chess game. From computer science perspective, if you just want to enumerate all possible playing steps in playing one Go, right, the number of those possible steps, right, covering the whole sample space, will be much bigger than the total number of atoms in the cosmos. So it's kind of incredibly huge. And also this number of like steps, like layouts in Go game is like many orders of magnitudes bigger than the chess game. That's why those methods which can win Kasparov cannot be used to win some like even mediocre human Go game players. Right? So I think in the 1990s, the richest person in the world is Bill Gates, the founder of Microsoft. He was very interested in this thing, in this Go game. He wanted to develop some machine player which can beat human players. So it came out. He reached out to some researchers in China because Go game originated from China, but then that researcher rejected because he thought it's too difficult. He was not willing to spend a lot of time and resources in doing some kind of impossible things. But now everybody knows that just a few years ago, right? Even after Deep Blue defeated Kasparov, like after 20 years, we have already had machine learning algorithms, AlphaGo, who can beat the strongest Go game player in the world. Right? This is incredible improvement, right? It's very incredible improvement. But if you're interested in that, actually the basic idea is not that hard. It's called the Monte Carlo tree search, and you have to use very smart layout evaluation mechanism. So this is like highly complicated functions. So they use a neural network, deep neural network, to evaluate those goodness or badness of this layout and determine where should we place the next piece. So this is one I think very famous example showing the power of machine learning in recent years. Right? But in addition to that, actually, in our daily lives, machine learning is everywhere. Like every time when you log into the Amazon, when you see this recommendation, they are done by machine learning. Sometimes I feel it is kind of annoying, but be patient. They want to earn some money, right? So they are based upon your, the purchase history and whatever profile information collected from your transaction and whatever. They want to predict something you might be willing to purchase, right? Sometimes I feel like their recommendation is really good. They indeed incur my desire to purchase more. Right? This is not good. And also spam email filtering. Right? This is kind of like a basic function in your email box, right? If you don't have like spam filtering function, then your email box will be filled out with fraudulent emails, like and trash emails, right? Those these are done by machine learning, and actually, after taking this class, everybody should be able to implement your own spam filtering algorithm. And voice recognition, right? So if you use iPhone or many other like intelligent cell phones, there are many such kind of services. Like you call Siri, you ask Siri to make a schedule calendar, send a message, query the weather, and etc. Right? And also like Alexa, right? Alexa in Amazon, developed by Amazon, is very convenient to use, right? So let us look at this example, right? What is this?
Upside down.
What is this? It's a helicopter, right? It's a drone, yeah. But it's not a broken drone. It's not an agriculture drone. It's just some kind of like demo. Right? So it's just some helicopter, but it's not real helicopter. It's some drone, yeah. And it is flying, and it's flying normally. This image is a normal image. It's not pre-processed image or special processed image. And this image is showing that this drone is flying reversely. So you can see that the helicopter, the propeller is running at the bottom, and the body of this helicopter is in the up. So someone may ask, is it possible? Yeah, it is possible. If you go to YouTube and search for like Stanford helicopter, they will show a video of this. And you see that at the beginning, they're flying normally, right? Flying according to our common sense, right? The propellers should be running on the top, right? But later, after some kind of adjusting and perturbating, and finally, they fly in this gesture very stably. And this is not done by human beings. This is done by some machine learning algorithms. So flying helicopter is really difficult. It's really difficult. It's not even you want to fly normally, it's not that easy. You have to be trained, right? But imagine that how challenging if you want to fly reversely, right? But machine learning algorithm can do that. And the team who developed this, their paper has received the best application award of machine learning in 2008 or 2010. I forgot, but quite a few years ago. Right? And this one, like self-driving cars, right? This already been in service, right? Google has deployed his self-driving like rental cars and bus in Phoenix City in Arizona. Right? If you have you can search it a little bit. If you have if you had a chance to go to Phoenix City, probably you can try to experience that. It's said that it's pretty comfortable and stable and robust. Right? Of course, if you drive like Tesla vehicle, they have like autopilot as well. Honestly, I really like this kind of function. If you drive on the highway, drive for long, it's very easy to get sleepy. At that time, if some kind of autopilot function can help me drive, I can snooze for a while. That would be perfect. Oh, someone asked OpenAI 5 is reinforcement learning rather than machine learning, right? So actually reinforcement learning is not a branch of machine learning. So basically they are all be characterized into a big class is called machine learning. Reinforcement learning is one of them. So actually the success of this helicopter and the AlphaGo game actually, resurgence the reinforcement learning. People found out reinforcement learning can be so powerful with complicated models like deep neural nets and big data. Okay, and the last example I want to highlight is the Google Translation. Right. So why? Because I'm saying how Google Translation grows from a crappy service to a very high quality service. So when its first version was released online, like people often play with that and mock that because it's so bad, right? It's very, very bad. Some most cases just give you some translation that nobody can understand. But nowadays, I think its progress is really amazing. Right? So if I want to write something, like because my native language is now English, my native language is Chinese, I just write down Chinese into this box and say what kind of English is good. Right? Sometimes it does give me some kind of good hint on that. So how does this translation service improve so fast? Machine learning. And especially with the popularity of big data plus recurrent neural networks. And recently, the recurrent neural networks was replaced by the so-called transformers. It's a more complicated sequence-to-sequence modeling tool. So if you're interested, I mean, all those kind of materials, things you can find examples in the web. And our course is just to give you the fundamental idea and important practice to let you easily dive into the technical details about all of those amazing techniques. Okay. So yeah, so I'm gonna skip those examples because too many examples, right? So now I'm saying how useful machine learning is, right? And how close it is to our daily lives. Now, we need to give a definition, right? Because we want to learn that, we need to know a proper definition of machine learning. So I'm going to start with the very first definition from Arthur Samuel, who is a pioneer in this area. In the 1950s, he defined what is machine learning. He said, machine learning is a field of study that gives computers the capability to learn without being explicitly programmed. The language is kind of a little bit, twisted, right? So but basically what he said is that, okay, if I want a computer program to learn, right, I do not want to explicit code any rules to generate predictions. I want it to automatically extract and construct rules from data rather than given by me, right? So like from the budget game example we just discussed, right? So if I write a program and I say, okay, if the number of letters of the first name is odd, then give negative, otherwise give positive label. This is not called learning. Actually, you want your program to automatically extract a rule like this, then your program is called machine learning program. And then Herbert Simon in 1983, he gives the learning in a more concrete way. He said learning is essential generalization. Right? So this point actually has been mentioned by some of you, right? Just when we discuss about definition. Right? So he said that learning denotes changes in the system that are adaptive in the sense that they enable the system to do the task or tasks drawn from the same population more effectively the next time. Right? More effective means that, okay, you're doing better from learning from the experience, right? Okay, so now let us come to a more formal definition of machine learning, which is favored by computer scientists, right? So this is given by Tom Michel. He said that machine learning is like this, right? A computer program is said to learn from experience E with respect to some class of tasks T, and performs measure P if its performance at tasks T measured by P improves with experience E. Right? It's a little boring, but it actually introduces several important components in machine learning. Right? First, experience E. Right? So if you want to learn something, you need to prepare some experience, right? In computer science term, that means data. You need to prepare some data. Data includes the experience. And you need to define what kind of task you want to learn from. You want to classify the badges, or you want to predict tomorrow, if tomorrow is raining or not, right? And in addition to that, to measure your improvement, we have to define some measurement. For example, classification accuracy. For example, like square error from the prediction, right? If your prediction is some kind of continuous values. Right? So I want to reiterate again, right? To have you understand, have you going through this idea to define learning as a generalization, right? So a computer program is said to learn from some experience E, meaning training data, with respect to some task T, meaning that, okay, to conduct machine learning, we need to define tasks. And we need to give some measurement P. If we can observe that your computer program's performance at your designated task T improves with your prepared data, and such improvement can be measured by the selected measurement P. Then you say, okay, your program is learning. Does it make sense? Okay, any questions so far? Yeah, feel free to interrupt me. Yeah, don't be shy because we're not meeting in person. But even we're in the in-classroom teaching, just feel free to interrupt me. I would love to discuss with you. Right? Or you can just write down some message in the chat. But I would just look at the chat box from time to time. So any question about the learning, the definition of learning? Right? So this definition actually directly tells you learning is a better capability to generalize. Right? Basically, that means if you simply memorize the training examples you have seen, that is not called learning. You must have some capability to better deal with some unseen examples. Like in this case, right? So suppose I have given your program a set of pictures, dogs, right? All kinds of dogs. Right? But if your program just memorize those dogs, that's not sufficient. Only when I give you a new dog, right? This new dog who wears a cool pair of cool glasses, right? If your program is still say, okay, this dog, it's not cat, it's not horse. That means, okay, your computer, your program actually generalizes. The program learns the concept of the dogs from this training set, right? Yeah, and the interesting experience is that I have an iPad, and I think the new iPad, they have Face ID, right? So you guys have used Face ID before, right? Right. So basically, they do not use fingerprint. They just take picture of your faces in many angles, and in a few minutes they kind of like know you next time when you open up iPad and they just scan your face and they will let you, they will unlock if you're really you, right? It is interesting. I found that, okay, when I make this face ID, I wear this pair of gloves, right? And after I try a few times, when I take off my gloves, they can still unlock the iPad. So this is another example of generalization, right? That means, okay, they not only just memorize me, right? A guy who wears a pair of glasses, right? When I take off the glass, they still recognize me, right? That's the essence of learning, right? If I switch my clothes, right? If I wear a T-shirt, they should be able to recognize me as well. Right? This is called learning. Right? Otherwise, it's just simple memorizing. Okay. So motivation, why study machine learning, right? Is it because machine learning is hot? It's so popular? It's so, it's kind of buzzwords, machine learning, artificial intelligence. Well, partly, yes. It's useful. It's popular. It's very natural. You want to learn that. I'm happy you're doing so, right? But in addition to that, right, what other important things can machine learning bring us, right? I think underlying this popularity, there must be some reasons, right? So first, with machine learning, we can build a more powerful computer programs, a system with new capability. Right? That's very important because human beings are tired of like doing everything from scratch by themselves, right? If we can automate those stuffs, right, we can construct intelligent system which can deal with can deal with new tasks by themselves, right? What you do is just collect data and let them train. That's perfect. Right? And from another perspective, like from a scientific perspective, right? So machine learning also helps us to understand nature of human learning. Right? So human beings is kind of amazing species. We can learn something, right? We can improve all the time, right? But how we achieve this? It's still unknown, right? People are still working on that, right? So there are kind of like research that trying to align the artificial neural nets and real biological neural nets and want to extract some competence to explain the learning behaviors, like in what kind of like cells, neural cells, and what kind of neural signals can explain some kind of behaviors. And what is the ultimate goal of machine learning? Right? The ultimate goal of machine learning, also the artificial intelligence, will be develop robots that can learn as well as human beings, right? So there are kind of like concerns right now. Some people and even some kind of big guys in the industry and saying they expressing the concern about the artificial intelligence that they're developing so fast, and what if like human beings will be ruled by robots in the future? Well, I appreciate their vision, but even machine learning has achieved so much great progress so far. It's still far away. It's still I mean, in the foreseen future, I didn't see that possibility. As you say, when you take this class and when you implement your own machine learning models and algorithms, and when you gain experience, you will see that. So all kind of machine learning models and algorithms are a set of like mathematical models and optimization procedures. It's hard to say they're intelligent, although in many tasks they behave like intelligent things. Okay. So any questions so far? Yeah, feel free to ask me any question. Right? Feel free to interact with me. So and machine learning definitely is a future. I've seen many claims saying that when I started doing my PhD study in machine learning, instead of machine learning is a too hot it's gonna, it's gonna be outdated. People will will transit their attention. They will like other things, right? But you say after 10 years, after 20 years, it's still very hot. Why? Because it's so useful. And also, machine learning is still quite far away from like satisfy everybody in every detail. So there's a big growth space, right? Especially with the growth with the era of the big data. So why do we see the amazing progress like in AlphaGo or in self-driving cars? The most important factor is actually big data. So like deep neural nets, neural networks, all those kind of things have already been invented in 1980s. There's nothing brand new in technical perspective. But people did not find they're so useful and so powerful until they try to fit big data into this complicated machine learning models. They found that they are working so well. So big data actually gives actually dramatically enables many possibilities. And also, we have seen that machine learning has been integrated into many end user facing applications every day. Right? Okay, so those are basically like advertisement of my class, right? Saying, I just want to tell you, machine learning is popular, but it's not like a hype. It's really useful. It actually is penetrating our daily lives. It brings a lot of convenience in our daily lives. And now going back to our course, right? This course is kind of entry level machine learning course. Oh, I want to raise a message from Tusha. Machine learning has also raised ethical concerns because of applications like deep fakes. So more machine learning might also result in more bad applications. Yes, excellent point. Yeah, this is something. This is something indeed really raise our concerns. Like probably we don't have a chance to introduce in our work. There is a very popular technique called GAN, general adversary neural networks. They can fake news. They can fake videos. It's very looks very real. And also, so there's a trend of like there's some kind of important or rising research areas. It's called algorithmic fairness, machine learning fairness, and differential privacy to tackle this problem. Like how do you ensure your machine learning models are ethical, right? Obey the human morality, right? And how to be fair, how to encode our fairness into machine learning model design. All those kind of things are really important. But from research perspective, that means many things we need to be done, right? Many things we need to make efforts to do that, right? But in other words, there are a lot of chances in this area. Okay, so yeah, happy to see more discussions in the chat box, right? Well, but now let us talk about the course content. But after all, our task for this course is to know what is machine learning, right? So this course will focus on the underlying concepts and algorithmic ideas in the field of machine learning. So in other words, we're gonna not, this course is not like a set of tutorials of using different machine learning algorithms. So like scikit-learn. So I assume that everybody in this class is able to do this by yourself. Instead, we're gonna introduce the key ideas, the core concepts of machine learning. Once you know this, once you gain a capability of developing machine learning, implementing and developing machine learning algorithms, it will be very easy for you to dive into any specific area of machine learning and learn any popular models and algorithms. This is our goal, right? Our goal is not train you to be familiar with some specific machine learning library. This is not our task. And also, this course is not about a single learning paradigm. I know some students is really passionate about deep learning. Our department has some courses called, I forgot. There should be some courses called deep learning and deep learning and structured learning. They will teach a lot of like deep learning models, like long short-term memories, like convolutional neural nets, and transformers, all kinds of stuff. And if you're really interested in that, you can take that course. Right? But this course want to give you an overall view of machine learning. What is the underlying concepts? What we care about? What is the common idea behind that? And also want you to develop your own machine learning algorithms. We want you to practice machine learning. We want you to gain experience in machine learning. Okay, so how will you learn this class, right? So first and foremost, please take classes to learn the models and algorithm, right? So although we are doing this online teaching, but if you take the class in this online classroom and effectively follow the instructor, and if you can interact with the instructor, that will be even better. Then your learning will be very, very efficient and effective. Right? So that's what I always suggested to my students before I try to highly efficiently utilize this 1.5 hours. And then you do not need to spend a lot of more time to watch the videos 1,000 times and figure out details. It's not necessary. It's inefficient, right? Just take the class and get an idea of the models and algorithm and go back to look at slides if you're unclear about that, and go to the office hour. That's it. And then second thing is, and also very important, finish the homework assignments to deepen your understanding. This is very important. Without practice, you'll never be able to really understand those concepts. Right? And implement the learning models and algorithm by yourself. Right? This is not just talking on papers. You need to do it by yourself. You need to show the code. And finally, do a course project. So everybody needs to do a course project using machine learning to address a problem. Right? I will introduce the requirements for the course project later, but this one is very important. So any questions so far before I introduce the workload? So is everybody happy so far? Okay. Yeah, sounds good. So now I want to talk about workload, right? So I want to put everything in front of you so that everybody is prepared, right? Is well prepared. So first, we're gonna have like 6 homework assignments. So basically, every 2 weeks, we're gonna have 1 homework assignment, and the deadline might be subject to change if many students require some kind of delay. That's fine, right? But these homework assignments are kind of heavy. It will include both the paper problems, it's called LaTeX problem, and the program problems. So by the way, all the homework assignments, when you finish homework assignment, you need to write them in LaTeX. We will provide the LaTeX template to make you feel convenient, but we do not accept any other written like written. If you just written on papers, something that scan it and submit, we won't accept that. And also programming problems. You need to implement the models and algorithm we discussed in the class, and perhaps you have to implement some variants on that. And you need to test your own algorithms and models with real data and report performance. And also discuss your opinion about the results, your analysis. Those are about homework assignments. Right? And then project. Right? So as I just mentioned, you need to do a project, either some kind of competitive project, which is essentially a Kaggle computation task, or exploratory project, which you can do some kind of study. You want to address some problem with machine learning, and you need to implement those machine learning models by yourself, and you need to write a report and tell me how effective your models are, or it is just not effective, and why, and what is your future plan, etc. And then we have a final exam. So we will not have like middle exam. This is to alleviate your overhead. I don't want too many exams, because exam actually turns out do not really reflect if you haven't really learned something. I want you to focus more on homework assignments and projects. Okay. So here, someone asked, for the assignments, will be graded on our coding structure or just on whether or not we come to the correct solution with our code? That's a very good question. Actually, it relies on both. Right? So even your program, your implement algorithms does not give the accurate answer at every point. We still look at your logic flows, your structures. If your logic flow, your implementation is correct, then you still have a good grade on that. Of course, if you haven't got a full score, you have to be correct in every aspect, right? And okay, thanks for the messages, but here let me first finish the warning message. This is very important. So you have about 2 weeks to decide, right? So here's the warning message. This course is one of the most challenging courses in CS department, right? It's not because the instructor is me, right? If you take class in the fall semester, the same warning message applies. So the workload is very heavy, and if you want to be effective, you have to get a satisfactory grade. I highly suggest you to plan for around like 20 hours per week. Right? If you do not commit enough time of doing that, you will not feel comfortable. You might be suffer from this course. So yeah, so I request you guys to be really cautious before you make the final decision, like whether to choose this course or not. Right? This is not to discourage you discourage you. This is just to emphasize that this course is really kind of like a hardcore course. It's not something like after taking this class very easily, I got an A, and I can see that I can tell the world that I'm an expert in machine learning. It's not like that. You must make efforts to learn something from this course. Okay. Okay. So someone asked, it's very interesting, but is 20 hours per week an average or upper limit or minimum? Why is our average? It's not. It's not accurate. Like somebody, maybe this course content is too simple to you. You say, okay, it's 20 hours is kind of is too much, right? I can spend 10 hours, or even 2 hours. It's fine. If you're that good, it's still fine, right? I mean, on average, you have to plan for plenty of time of that. If you don't have like relative experience on that, on this course. And yeah, which programming language should be used for assignments? That's a good question as well. I will discuss about it when we walk through the syllabus. But basically, we highly encourage you to use Python, to use MATLAB, to use R language. But we're not limited to some specific language. If you insist on implementing your models with C++, or even assembly language, it's up to you. But I will tell you what's the benefit of using Python. And someone asked the review and lecture slides. Yeah, they will be posted on course web page. I'm not gonna post the slides on Canvas because it is less easier to download. I will just post all the slides on the course web page, so it is very easy for you to download and review. And should we be able to answer all homework 0 with previous knowledge? Yeah, I think so. If you really feel difficult, you feel like I have never learned of this, so please talk to me. Okay, we need to look at your background and figure out a way to address the problem. And another question: are we allowed to switch the programming language we use between assignments, and do we have to pick up one for the whole course? Of course, you're free to choose whatever language you're familiar with, right? You can use Python in homework 1 and use MATLAB in homework 2, or use C++ in homework 3. It's up to you. It's up to you. Okay. Any other question before we trying to walk through the syllabus? Okay. So another thing I want to emphasize that so this semester we're going to use Piazza for class support. So we'll still release announcements in Canvas in case that like we want to broadcast our most important announcements in every possible ways, but we'll mainly focus on Piazza because our department generously purchased Piazza license. It is much more convenient to use, especially to answer your questions. Because in our previous experience, there are always students complaining that, okay, why my questions on Canvas cannot be responded in time. This is partly because I think the user interface for Canvas is not really good, and every a few minutes you have to verify with your cell phone and re-log in. It's really inconvenient. But for Piazza, it's like online forum. As long as you post your question on that, our TM can see your question immediately from the website. They can post it immediately, and I will watch the Piazza Q&A session as well. Okay. So, oh, by the way, if you happen to register just today or tomorrow, or even in this week, so that you haven't received the activation email from Piazza, just look at the Canvas notice. There is one notice said Piazza activation. There's a link. There's a link to enroll in the Piazza course, and also the access code is there. You can use that to simply to register. Okay. Okay. So now I want to walk through the syllabus so that we can let you know how the detailed schedule of this class, and also the grading criterion, and also other logistics to help you decide whether you're gonna finally take this class. Okay. So first, I will click into this course web page. So so let me switch to this course website. So can everybody see the course website? Yeah, this is a very important website because it contains all the important information in this class. So it is actually a links to my homepage. So this is my homepage. You can look at my homepage, just simply search my name, Shandianzi, UFU, or U or Shandianzi in Google, and you can come to this page. And here there's a teaching section, right? So the link to the course. Okay. When you come to this web page, you'll say it includes everything, right? So this is the main page of this course. So you see this schedule, Tuesday and Thursday at Zoom time, right? And this is Zoom link. But I did not post the passcode here because I don't want like some someone else to occupy your seats, right? Because we have a limited number of the Zoom lecture room, right? And also the Piazza link. So basically, you can click this Piazza link to ask questions and whatever. So let me log into that. Oh, sorry, I should use my email. So you can see that we have a release of homework 0. We have released the TM online office hour. By the way, TM online office hour is already released in Canvas. You can check it out if you haven't registered, you haven't enrolled in Piazza. And also the online lecture, Zoom lecture invitation. So we always use this link. So if you want to some kind of reminder, you see the link here, right? So just click the link and just click the link here, and it will download some kind of ICS file. So you click that, it will automatically set up the calendar and remind you before every class. Very convenient. That is very convenient. I highly suggest you to use. And don't forget, our lecture has passcode, so I'll highlight here. Okay. And also you can post your question, like you see the Q&A section, right? So under, say somebody might have a question about homework 0, feel free to post your question and issue discussions here. But remember, do not release the answers. If you find that you're telling anyone else that the answers, will immediately delete your post. Okay. Okay, so let's go back to the course web page, and the final exam here. So it's on May 3rd, 10:30 to 12:30. So the official schedule is here. You can check it out. And this is going back to my homepage, and also my email address. And then we have 2 teaching mentees, Jun Wang and Shibo Li, and they have they are very good. And another thing is that I want to emphasize, we have office hours every day, every weekday. So to me, the office hour will be right after the class, from like 1:50 to 3 p.m. And to the other teaching mentees, they have office hours on Monday, Friday, and Wednesday, Friday. So that means every weekday we have about like 2 hours office hours. So please don't waste those resources, right? We're ready to help you every day. Don't feel shy, and feel free to talk to discuss with me or our teaching mentees whatever questions regarding the course. Okay. Okay, so now I want to go through the syllabus with you. So those are course web page and teaching mentee office hour. Those are the same as the course web page, and the description here. I just want to read it through read it through to just let you know what kind of expectation of the outcome. Right? So the course introduces the basic knowledge of machine learning. Topics consist of several fundamental and widely successful supervised and unsupervised learning algorithms such as decision trees, perceptron, deep neural networks, kernel methods, support vector machines, and probability methods. So after taking the class, we hope that you will first understand machine learning ideas and paradigms. This is the most important thing. Secondly, be able to identify appropriate machine learning problems for your research applications, meaning that you can formulate the machine learning problems by yourself. And third, be able to design machine learning models or to implement learning algorithms by yourself. I'm pretty much sure you will be able to achieve that if you finish all the homeworks, because all those homeworks are requiring you to implement those algorithms by yourself, implement it, debug it, and test it. Okay. Oh, someone asked how large the work gap between 500 level students and 600 level students. So actually, the workload is kind of pretty the same, but the criterion to receive the A+ or B+ A are different. So we'll talk about later. Okay. So books. We do not require you to purchase some books. So the books are not required. So the lecture slides will are self-contained, right? They cover all the content, but we list several books to extend the depth and breadth. If you if you have more time, you're willing to dig more, right? So here we give a few references, like the machine learning and probabilistic perspective. Some professor written in 2012 is a thick book, and Christopher Bishop pattern recognition and machine learning is very classical machine learning entry-level course, which I used in my PhD study. And this Haidong a course in machine learning this is kind of online. We have an online version. You can just read it online. And Trivial History is another book. It's called The Elements of Statistical Learning. This is a very classical book. They introduced machine learning from like a statistic and frequentist, especially frequentist statistics point of view. And David Mikai, this is another early classical book. It's called Information Theory, Inference Learning Algorithms. Again, these books are not obligatory. If you're interested, feel free to look at them. Most of them are free to download. If you don't have time, you can just focus on our lecture slides and homeworks and so on. Okay. And prerequisites. So I'm not willing to read out those prerequisites, but I just want to emphasize why do we talk about, why do we make these prerequisites? So we just want you to be well prepared to take this class, not be hurt by this class, not suffer from this class. So what does it mean being like to be well prepared? So basically, if you know basics of probability theory and statistics, that would be good. That would be good, right? You know what is uniform random variable, what is expectation, what is variance, what is Gaussian distribution, and that'll be full. That'll be good. And also, we request you to be familiar with linear algebra, especially vector and matrices derivatives. These are very important because in machine learning world, especially the mathematical part, most of the time we're dealing with matrices and vectors. Consider that we're optimizing a deep neural nets like with millions of parameters, right? So we derive the equations. We're operating the whole vector of neural net parameters. We're not going to look at each element of the neural network weight, like one by one, right? That's too inefficient. Right? So we'll only look at vector matrix. Right? So when you implement your least mean square error training method, you implement your own gradient descent, right? You're operating with the gradient vectors rather than each gradient, right? The gradient of each element, each variable. So please get familiar with your linear algebra course. If you forgot the basic knowledge, just open it, right? and look at them, right? And doing homework 0. And also, we hope that you have algorithmic design and programming skills. This is also important because, as I emphasized, right? So we need to implement and debug those algorithms by yourself. Right? You need to be able to, of course, some skill of implementation. Right? You need to be able to debug, right? So we won't be able to help you debug your code. Right? You should be able to debug. You should look at, okay, step by step, and then which variable, what is the value? It is a normal in this step. And should I rerun? Should I print out all the running information? Those kind of things to make sure your implementation is correct. Does it make sense? Any questions so far? Okay, so yeah, I hope everybody is happy now. Everybody is still happy, right? Okay, so getting help. Right? This is actually this is actually really important, and I want to emphasize again, right? So as we mentioned, right, to help you, to try our best to help you guys, right, to help the students, we intentionally schedule office hour every weekday, right? So I really hope everyone can take advantage of the instructor and TA's office hours. And we'll work hard to be accessible to students. Right? And but otherwise, I mean, if you want to meet in Zoom, but you're not you another time, yeah, you can send an email to me or to TM and to schedule another time. Right? But don't be shy and don't hide the problems. Like if you're unclear about something, about course content or homework assignments, or you want to get some, you want to be enlightened by someone else, like by TM, feel free to join the office hour. Right? And don't waste those good resources. And also, our class will heavily rely on the Piazza Q&A session. Right? So feel free to post your questions and discuss with others on Piazza. And our TM will always watch the Q&A session, and will kick in if you need help. Right? And they'll try their best to respond immediately, except that in the weekends you might need to wait for a while because they have their own things to do. But other than that, I have told them try to respond as quickly as they can. Okay. And I would love to see any kind of discussions, right, related to homework and related to the course. But there's one principle: do not post potential homework answers. Right? So if someone asks, do you have any idea how to work out this? You can say generally, okay, you should do this, you should do this, but do not give the details. Right? Do not give the answers. If you find such kind of post, we're gonna immediately remove your post and tell you not to do that next time. Okay. Yeah. Any questions so far? Yeah, great. So so I guess we need to stop here today. So we haven't finished up, the working through the whole syllabus. So please bear with me. This sounds a little bit boring. This is just like we haven't started with the intro, right? This is just an appetizer. But I want to let everybody know the whole schedule and the whole challenge, the whole task let you to make a full evaluation. And if you really want to take this class, you want to enter into machine learning, please commit enough time and please be prepared. And next, in the next lecture, I will walk through the remaining parts of the syllabus and also talk about the the project section. This is very important. You need to prepare the project right now, and then we'll start talk about like basic knowledge review, and then our first machine learning topic model. Machine learning model should be decision trees. Okay. Oh, that's a good question. Someone asked, is a project team project or individually? Actually, you can do it both. We have two types of project. We're gonna discuss it on Thursday. Okay. Okay, great. Thanks everybody. And now from now to 3 p.m. is my office hour. So I guess nobody will have questions right now. So yeah, just feel free. If you want to ask, feel free to ask. Otherwise, we'll see you on Thursday.
Hey, I just had a quick question based on
Yep.
what I saw in Homework 0. I saw one of the questions asked to prove, if A is equal to A plus B. Are there going to be a lot of formal proofs in the future homework assignments, or is that just kind of based knowledge, previous knowledge on proofs?
No.
Okay.
This course is just, I mean, homework 0 is just like kind of like warm up.
Yeah.
Yeah.
Yeah. I was just wondering if that would be reflective of like future homework assignments or something like that, because
No, it's from homework
that
one,
is
would
not
be
my
very
strong
different.
suit. Is proven stuff. I just wanted to get an idea.
Okay.
So,
Okay.
okay. Thank you.
Yeah, no problem.
So I had a question about the homework.
Oh, okay.
Well, I was looking at it, and like I got good grades in stats and linear algebra. I got A's in both of those classes, and there's some topics on this that I'm unfamiliar with, or I don't remember how to approach. Any advice on what I should do at this point?
Oh, yeah, that's that's a good point. I would suggest you to open the book and look at. So those are which problems are you feel uncomfortable?
Well, like question 3, I'm a little unfamiliar with the like notation there. It might be a problem that I know how to do. It's just I don't know what.
Yeah, can you give me 1 second? I just take a look. Question 3. Oh. Oh, this is about like I think this topic should be covered in your intro level of the probability and the statistics.
Okay, maybe I forgot it.
Yeah, you can take a look. There actually a general equation tell you how to compute the probability of union of set events. Try to find out the equation, but there are simpler proof for that.
Okay.
Like I give you the hint, right? It's said like by induction.
Yeah.
You can try to start from like 2 variable cases and then you know try to generalize it to like arbitrary number of events. If you still feel like uncomfortable, we can talk about on Thursday or you can talk to the TM like tomorrow.
Okay.
Okay.
One more thing. You said something about like looking at the book. Are you referring to like my stats book that I used previously, or is there a textbook that you suggest?
I think your previous book should be fine.
Okay.
You haven't taken the introduction to statistics or probability, such kind of courses, right?
I took engineering stats last semester.
Oh yeah, okay. I think it should cover like they should define what is the events, right? They use sets to represent events, right? And the union of the size represent the event that A or B, and the intersection of the sets represent A and B both happen. Those should be covered by every book.
Yeah, it was just the the U to the N and the I equals 1. I don't think I've seen that. It does sound like something we've talked about. It's just that specific notation. So I'll look.
Oh
back.
yeah. That notation is just saying okay, A1 union with A2 union with A3 until union.
Oh,
with
okay.
and nothing else.
Okay.
Yeah.
Yep. I think I should be good on that one now. Thank you.
No problem.
Hello.
Hi.
Hi. So can we discuss solutions with you? Like I have a doubt in question 5. So here the mean that I evaluated is coming as a function of x. Is that okay? Like should it come as a function of x?
Can you say it again? I didn't get a point.
So the question number 5, it says that the random variable follows a standard normal distribution with mean 0 and variance 1. And it is the function, a new random variable is a function of the previous random variable x. So, right. So for calculating mean, there is a direct formula. I recall from my memory that there is a direct formula where you can directly calculate the mean of the new random variable, and when I evaluate that, it comes as the final equation comes as like mean of y is equal to a function of x, like some
Yes.
function,
Yes.
right? So is it okay to leave at that point, like as a function of x, the equation?
Yeah, it's okay because y is a function of x, right? Expectation of y is actually expectation of function of x.
Correct. Okay. That's then that's fine. And for question 6, we can use directly the theorem that is behind it. Like for the first part, I think there is a direct theorem that states the same thing. Do we need to like write down the proof for that?
Yeah, you need to write down the proof.
Okay.
Of course, these are two well-known theorems for statistics, right?
Right. So
Students
I
say,
was
okay,
able
because they are known theorems, so I do not need to prove.
Yeah, no. So I was able to prove the second one using the first one.
Oh, that's fine. That's fine.
Yeah, but I'm still not getting my head around how to prove the first one. Like so.
Oh, really?
Yeah. So because it seems simple enough, but I'm not sure about whether my solution is correct or not. Is like I tried to do it, but it seems like it's only 2 or 3 lines of proof. Nothing else is needed there. I'm not so sure.
I'll give you a hint. You can consider joint probability, right?
No.
You consider the joint probability of y and x,
Okay.
and you decompose the joint probability by p of x times p of y given x. Then you should be able to derive a proof A.
Okay. I'll try that. Thanks.